Hello class, this is a lecture on using the properties of exponents with scientific notation. Scientific notation is a concept that is review for you guys. You would have learned about it in probably a previous algebra class, and you used it probably in science. And then we're going to use the properties of exponents that we learned in section 7.1 to 7.3 together with this review concept of scientific notation. Just in case you don't remember what scientific notation is or never actually learned it, scientific notation is a method used in science or math to describe either very small numbers or very large numbers. It's going to be written like this: a times 10 to the b power, where a has to be a number between 1 and 10. That's important. A has to be a number between 1 and 10, and b is the number of times you should move the decimal place. You are going to see that when we are discussing very large numbers, the exponent here is going to be a positive number. And when we are discussing very small numbers, the exponent is going to be or a negative number. One thing that I discussed in the previous lectures is this is the only time that you're going to be allowed to have negative exponents in your final answer, is with scientific notation. And remember, a negative exponent is just going to say that the number is very, very small. So here's an example of scientific notation. Actually, here's two. If you had this number right here, this is the number in scientific notation. It's 3.4 times 10 to the 7th power. This number here, this is the a, this is a number between 1 and 10. And then this is the number of times, the 7 is the number of times you would move the decimal place. And this is how it would be written. So how you would actually do this is you would say, okay, 3.4 times 10 to the 7th, so you'd have to move the decimal place 7 times. And because it's positive, you're going to move the decimal place to the right. So you'd move it 1 time, 2 times, 3 times, 4 times, 5 times, 6 times, 7 times. This is where the decimal should go. And what you're just going to do is put zeros in there in between. So 3.4 times 10 to the 7th is this number. On the other hand, if you were given 3.4 times 10 to the negative 7th, that's telling you the number is very small. So in that case, what you would do is you would move the decimal place to the left. If you have a negative exponent, you're going to move the decimal place to the left the number of times that it says. So you move this one to the left 7 times. 1 time to the left, 2, 3, 4, 5, 6, 7. That's where the decimal is supposed to go. And you'd fill in the rest with zeros. So that part should be review. That's really the entirety of just the part of understanding what scientific notation is. What we're going to do is we're going to use some operations with scientific notation. We're going to do 3 different ones. We're going to multiply with scientific notation. We're going to divide. And the third one is going to be a number in scientific notation to an exponent. Those are the 3 things that we are going to be covering. So let's say you had the number 2.3 times 10 to the 5th, and you were multiplying that by 1.9 times 10 to the 8th. How you would actually do this multiplication is you're going to take the 2 numbers and multiply those. 2.3 times 1.9 is 4.37. So you'd multiply those numbers together, and then for their exponents, you would multiply these together as well. And remember, when you multiply with the same base, these are both base 10, when you multiply with the same base, you add their exponents. So this would be 4.37 times 10 to the 13th power. We got the 13 because we added those things together. Here's another example I have. This one is going to be a little bit more challenging, but the concept is the same. You would multiply the 2 a terms together. 5.3 times 7.9 will give you 41.87. This would be times 10 to the 10th power. Now, we have an issue here. We have 41.87, but 41.87 is not between 1 and 10. Remember, this number has to be between 1 and 10 for it to be an actual scientific notation. So what we're going to do is we are going to move the decimal place over 1 time. So this will be actually 4.187 times 10. When we move the decimal place over 1 time, we are going to change the exponent to make it still say the same thing. If your number is too big and you have to decrease it, you're going to increase the exponent. Because our number was too big, that's going to cause our exponent to increase when we made this number between 1 and 10. So this would actually be 4.187 times 10 to the 11th. That would be how it would be written in scientific notation. I have 2 more examples here. Why don't you guys try these 2? Pause it here, see how you do, then evaluate how you did when I go over it right now. So this first one, 3.3 times 2.9 is 9.57 times 10. Remember, when you multiply with the same base, you add their exponents. 7 and negative 3 will give you 4. My number is already between 1 and 10, so we're good. This is just my answer. But for this one, it's not going to be as easy. 6.3 times 2.9 is 18.27 times 10. And then remember, you would add their exponents and you would get negative 4. Now here, once again, my number is too large. 18.27 is too big of a number. So decreasing it here is going to cause me to increase the exponent. So 1.827 times 10. Increasing the exponent by 1 here is going to make it negative 3, and that will be my answer. So this is the examples where you are taking a number in scientific notation and you're multiplying it by another number in scientific notation. We are also going to have problems where we would divide numbers in scientific notation. If you were doing 2.3 times 10 to the 5th divided by 1.9 times 10 to the 8th, you're going to divide the a terms. 2.3 divided by 1.9 is we'll call it 1.21 times 10. And then you would, when you're dividing, remember, with the properties of exponents, if they have the same base, you subtract their exponents. So you'd have 1.21 times 10 to the negative 3rd power. That would just be your answer. It's really nice when the number is already between 1 and 10, but in this one, that's not going to be the case. When you divide 5.3 and 7.9, you're going to get 0.67 about. Times 10. Remember, when you have the same base and you're dividing, you subtract their exponents, so times 10 to the 6th power. Now this number, remember, has to be between 1 and 10, and it isn't right now, so we're going to move the decimal place to fix that. So it would be 6.7 times 10. Okay, we had to increase our number, right? The number was too small. We had to increase it, and so when we increase it here, we're going to have to decrease the exponent. So it would be 6.7 times 10 to the 5th. Once again, go ahead and pause it here, see how you do. Then we'll see, you'll evaluate that when I go over it here now. 3.3 divided by 2.9 gives you 1.14 times 10. Here we are dividing with the same base, so you'd subtract their exponents, and 10 minus negative 3 is actually just 10. So 1.14 times 10 to the 10th power would be the answer there. And then the last one, 1.1 divided by 2.8 is 0.39 times 10. 4 minus a negative 8 is actually 12. Now remember, our number here is too small. We have to increase the number, and when we increase it over here, we are going to decrease the exponent. So our answer would be 3.9 times 10 to the 11th. Now my number is between 1 and 10, my a term, so that is a good answer. And then the last variety. This variety is going to be a number in scientific notation to a power. And in this variety, what you're going to do is you're going to take the to the fourth power and apply it to both things. So this would be 2.3 to the fourth power times 10 to the, remember, when you have a number being taken to a power being taken to another power, you actually multiply the exponents. And 2.3 to the fourth power is 27. We'll call it 27.9 times 10 to the 20th. My number here is not between 1 and 10. It's too big, so I'm going to make the number smaller. And when I make the number smaller here, I'm going to increase the exponent here. So this would be 2.79 times 10 to the 21st. Last problem we're going to do today, same idea. You're going to take this to the fourth power and you're going to apply it to the 5.3 and to the 8. 5.3 to the fourth power is 789 times 10 to the 32. Now, in this problem, the decimal place would be here. In order to get it to be a number between 1 and 10, you'd actually have to move the decimal place over twice. So it would be 7.89 times 10. The number was too big. I decreased it, so now I'm going to increase the exponent by 2 because I moved the decimal place over twice. So my number was too big, so I increased the exponent by 2 to make it 7.89 times 10 to the 34th. That is all I have for you guys today. You guys have a worksheet on this stuff on Schoology. Please let me know if you have any questions.